Last class, we talked about searching. There are two types of searching, linear search and binary search. I'm not sure how confident you are for the binary search, but this particular concept is really an important concept in computer science. Over the time, you need to get used to it, the binary search algorithm, is because you need to use those things in your upper division classes, or if you go to the industry, probably like a lot of industry are using this binary search technique. Okay. Now today we'll be discussing sorting. So what is the sorting? Like when you have a collection of item, sometimes you need to sort it, maybe by ascending way or by descending way. So there are various ways to sort those things. So what is the sorting? So sorting constitutes a fundamental operation in computational system, facilitating the organization for data structure for efficient access, manipulation, and presentation. In practice, sorting algorithms are integral to diverse applications such as ranked information retrieval, file system organization, and optimized search strategies. These particular operations are typically categorized in different ways. Whenever we have a numerical sorting, we typically arrange the numerical values. Sometimes we need to sort by lexicographical sorting, which is like an alphabetical precedence. Sometimes we need to use a criterion-based sorting. For example, like employees user-defined criteria such as string length or temporal marker to determine their order. Okay, so sorting is the process of arranging element in a specific order, either ascending or descending. So if it is a lexicographical, then it should also be ascending or descending way, for example, like A to Z or Z to A. If they are numerical, then ascending is like 1 to forward or the higher number to the lower number. So for example, this list 30, 10, 50, 20, if we'd like to sort it in an ascending way, it is like 10, 20, 30, 50. So far, we already have used a lot of sort, not a lot of, sum of function to sort. Two functions basically. One is like sort, and another is sorted. What is the difference between those two functions?
Sort is just for lists.
Okay.
And sorted is for a interval.
Why the sort is for list?
It's a function exclusive to lists. So sorted is like an in Python whole function. It's like sorted, and then what you want to sort is inside of the parentheses. If you're doing sort, that has to be list name dot sort.
Stephen?
Because sort is changing the original list, where sorted is returning a new list or new interval.
Yeah. So that's true. So first thing is sort and sorted. So whenever we're using sort, that means we need to use a sort for, sorry. So whenever we're using a sort, that means it is a method of any particular data structure. What data structure? Well, maybe a list data structure. And how do you know? Well, if you use the dir method, it will give you the list of methods of that particular data structure, right? That's why we cannot use the sort function to other data structures. This is the one thing. And the second thing, one Stephen told, like whenever you're Stephen, right? You are Stephen. Just to make sure I call you the right name. So for the sort, it changed the original data structure, but for the sorted, it sort and create a new one. So if you are going to use sort function over tuple, you cannot, because tuple cannot be modified by itself. You cannot modify it. So immutable things, right? That's why you need to use sort function to a mutable data structure. This is the first thing. But somehow dictionary doesn't have any sort function. Only list has. That's why we're using a sort function over the list, right? But they're doing the same thing. Both sort and sorted are sorting the elements, either descending or ascending. By default, it's sort by ascending way, but if you'd like to sort it descending way, you need to use a keyword called reverse equal true. It is like a flag or a parameter, which is like a default value is false. Reverse false is like it will sort in an ascending way. If you make it true, then it will update to the default parameter, then it will sort by the descending way. What other way we can sort a list in a descending way?
Reverse equals true in the parameters.
Yeah, that's the one way. But what is the other way? Is there any way we can sort a list by reverse way without using the reverse true? Remember? No? There is a function called reverse, right? If you sort it ascending way and then reverse it, then it is like descending sorting. I'm not using reverse keyword in a sorting, like sort function or sorted function. Then it will sort by ascending way. Then when I reverse it, now it's a descending sorting. Okay. So those are the constraints. So you need to know those type of constraints whenever you are applying for a job interview. They will looking for those type of constraint. Like whenever they're asking to solve a simple problem, they put a lot of constraint. Like you cannot use, for example, like you cannot use the reverse keyword, but you need to make a descending sorting. How do you do that? Yeah. So initially, like, so if you just use the reverse, then it will just reverse the list, not sorting. First, you need to sort it, then reverse it. Two operations. Okay. Those two are the built-in method in Python. So built-in means like there is like one built-in method, which is like a sorted, and one specific data structure method like dot sort, which is a list method. Okay, so sorting algorithm can be categorized in several ways. It could be comparison versus non-comparison, stability versus non-stability, internal or external, etc. A lot of other ways to categorize different sorting algorithm in computer science. Here's a list of common sorting algorithm grouped by their category. First is like simple sorting algorithm. These are like basic or educational type of things. They are very easy to understand, and often we can use those things to teach sorting concept. The very popular one or very common one is the bubble sort. We'll be discussing bubble sort in a moment. There are some other type of sorting algorithm like selection sort and insertion sort. I'm not going to cover those things in this class. Probably in 1410 or 2420, you will be learning those things in details. Just like a brief overview of sorting and searching. I'll be going through bubble sort definitely. A little bit about the merge sort, but not in detail. So what's the characteristics of those simple sorting algorithm? They are simple to implement, inefficient for larger data set. And if you're comparing the time, it is taking longer time. I'll show you why it is taking n squared time. What does mean by the n squared? Again, time complexity is a part of 2420 class, but I'll be going through the n squared thing in a different way, not a traditional way. But you will be learning those things in 2420 class. What is the time complexity, space complexity, order of n, and some other things. Okay. Then efficient comparison-based sorting algorithms are like these algorithms compare the elements to determine the order, like a merge sort, quick sort, heap sort, shell sort. Team sort is most popular in Python and Java. So what you are using in Python, like dot sort function or sorted function, basically internally they are doing the team sort. There's some other sort like tree sort. In C++, they are using the intro sort. And their complexity is like n log n. I'll be discussing those things again later. Some real, so there they're commonly used in real world application that I already told you, like team sort. We already use those things in Python, like dot sort function or sorted function. Merge sort is much more popular in case of sorting any data structure, where there are like three types of time complexity, like base case, average case, and the worst case. For example, the list is already sorted. That means this is the base case. You don't need to sort it. What is an average case? Like average number of elements are not sorted. This is the average case. And what's the worst case? All of them are sorted in a reverse way. This is the worst case scenario. You need to sort it in the reverse way. So in all three cases, merge sort is giving you the same complexity, but other sorting algorithm are giving you different time complexity in different cases. That's why merge sort is much more popular. The team sort is like a combined sort, like they're using two different types of sorting. That's why Python and Java are using the team sort, but I'm not going to discuss those things in details, just some overview. Then the third category is like non-comparison sorting algorithm. These algorithms do not compare the element directly. Instead, they rely on the properties such as digit or value ranges. So counting sort, radix sort, bucket sort, pigeonhole sort, those are the non-comparison sorting algorithm. And what are their characteristics? They are faster than the comparison sort. Sometimes they can achieve in a linear complexity, like search linear type. So you're just searching and sorting. So sometimes, not all the time. So that's why we are not using those things always. Maybe in a best case scenario, they are giving like order of n complexity. They can work under certain condition like limited value range. For those particular cases, those type of sorting may be helpful. Then the hybrid sorting, these algorithms combine the multiple sorting technique. That's what I told you about the team sort. Team sort is a combination of merge sort and the insertion sort. For example, like another one, the intro sort, they're using three different types of sorting algorithm, like a hybrid version of three different algorithms: quick sort, heap sort, and insertion sort. So as I told you, our built-in sorted function and the list dot sort function is using the team sort internally. It's like a hybrid sorting algorithm. Then the fifth category is parallel and advanced sorting algorithm. They are used in specialized system in high performance computing, like bitonic sort, odd even sort. You know, if it's like odd even, it is easy to distinguish. Sample sort, parallel merge sort, external merge sort, those are like parallel and advanced sorting algorithm. They are used in distributed system, GPU computing, or large scale databases. The last category is like external sorting algorithm. They are used when the data cannot fit into the memory. That means if the data is too large to fit in our RAM, then this type of sorting can be helpful. So external merge sort, polyphase merge, and replacement selection sorting are the technique to sort the item when the data cannot fit in a memory. They are common in database system, big data processing, file system. But what we already have known is our built-in sorting things like dot sort or sorted functions. I think you don't have any question about those two types of function. Like you already have used a lot. Any question about those two functions? So well, there's a fine line between function and method. Function, whenever I'm talking about the function, that means the built-in function. Whenever it's a method, that means it is a part of any data structure. So when I'm saying function, that means either function or method. So don't get confused. Method is in any particular data structure method, and function is like a built-in that can be applied to any data structure. Okay, and you already have known that how you can sort a nested list or nested tuple by their second item, third item, or so on and so forth item, right? You remember that? You need to use a parameter like key. In that particular parameter key, you need to use a function, or you can use the lambda function there to sort a nested collection or nested iterator by their second item, third item, or some other items. Okay, those are the variation. Any question about the built-in one? If you don't have any question, then we can jump to our very basic sorting algorithm, like a bubble sort. So I'm not going to discuss about those things again. Built-in sorting things we already have discussed over the semester. Sorted that can be applied to any data structure, and sort can only be applied to this list. The main difference is like sort only modifies the original list, but sorted will return a new one. For the descending order, you need to use the reverse equal true. And internally, it uses the team sort. Bubble sort. This is the very popular one and the very naive one. People use the bubble sort to understand how the sorting algorithm works. What is the bubble sort? So bubble sort is a simple sorting algorithm that repeatedly compares the adjacent element in a list or in an iterator and swaps them if they are in the wrong order. After each pass through the list, the largest unsorted element moves to its correct position at the end of the list. And this process continues until the entire list is sorted. That means we are bubbling up the correct position of the largest item every time. So let me write a list here. For example, an unsorted list like 5, 6, 2, 7, 3, 8, 1, 3, 4, 5, 6, 7. What did I miss? 4, right? So this is the list. What is the bubble sort? Bubble sort start with the first two numbers, 5 and 6. Are they in the right order? Yes, they are. So 5 and 6, it is there. Then next to adjacent. So you can think of it as a window, like two value window, just sliding the window. So now we just slide to there. 6 and 2. Are they in the right order? They are not. We're going to swap it. If we're going to swap it, then 2 is here, 6 is there. Then again, we change the window to here, 2 and 7. Basically, we already have swapped. It will check 6 and 7. So not 2 and 7, but 6 and 7. Are they in the right order? Yes, they are. So 7. Then 7 and 3. Are they in the right order? So we need to change it, or we need to swap it. 3 and 7. Then 7 and 8. Are they in the right order? Yes, they are. Then 8 and 1. Are they in the right order? No, they are not. So we need to swap it, 1 and 8. Then 8 and 4. Are they in the right order? They are not. So 4 and 8. That means we're pushing the highest number at the very end, like bubbling up the number at the right position. Then we are setting 8 in that place. That means 8 is the largest one. Now we need to iterate until 8 for the next run. This is the first run. Then after the first run, we have this value, this list. On the second iteration, we don't need to iterate until 8, but before 8. It's because 8 has its own position. Well, do it again. 2 and 5, 5 and 6, 6 and 3, replace it or swap it. 3 and 6, 6 and 7, 7 and 1. So 1 and 7, 7 and 4, swap it. 4 and 7. 8 is there. Now we'll lock the 7. The 7 and 8 are in the right position. So we don't need to iterate until 7, but before 7 in the next round. On the third run, we'll do the same thing, 2 and 5, fine, 5 and 3, no, swap. So 3 is here, 5 is there, 5 and 6, we don't need to do anything, 6 and 1, swap, 1 here, 6 there, 6 and 4, swap, 4 here, 6 there. Now we fix the 6 here. So 2, 3, 5, 1, 4, 6, 7, 8. On the next run, we need to iterate up to 4. That's because 6, 7, 8 are already in their right position. 2 and 3 is already sorted. 3 and 5 is already sorted. 5 and 1, no. Swap it. 1 and 5, 5 and 4, again, no. So now 5 is sorted. So 5, 6, 7, 8 are already sorted. On the next run, 2, 3 already sorted. 3, 1, no. So we'll swap it. 1 and 3. 3 and 4 already sorted. Now 4. 4, 5, 6, 7, and 8. Then on the next run, 2, 1. No. 1, 2. We'll swap it. 2 and 3. Yes, already sorted. Then up to 3. That means we fix the position for item 3. Now the last run, 1 and 2 are they sorted? Yes, they are already sorted. We don't need to do anything. So 1 and 2. This is how we can sort through the bubble sort. We are checking 2 adjacent element, and if it is not sorted, we'll sort it by swapping it. And at the very end, we have the largest number on that particular list. Okay. Now the question is, how many times we have done this operation? So for this case, we are just checking 2 adjacents, right? So 1 time, 2 time, 3 time, 4, 5, 6, and 7. That means if there are like 8 elements, we're checking n minus 1 time, or we can say like n time. So n time for checking item at 1 run. And how many run we have done here?
N minus 1.
N minus 1. Actually, it depends. It can be n minus 1, but it can be n minus I. But here I is negligible, so we can say it will take n times. So n times on each run and then n run. That means n multiply n. That's why you already have seen like order of n square. So it will run n time, and on each run it will check n times. I just omitted the negligible part like 1 or I. That's why it is taking n square time. If you remember the searching algorithm, we have search an item 1 at a time throughout the list. That's why it took like n time. Then for an efficient case, we have is a binary search. Then we have half the item at a time. Then the next run, we make it half again. That's why it took like log of 2 of n, right? So log of 2 on n is better than n, and obviously best than n square. So n square in this particular case, n square n and log n square is the worst case, like worst time. Then n mid-level, and log n is the best case. Okay. So in our case, n square, so we are getting n square for a bubble sort. Now there is something in between n and n square. This is like n log n. As we have seen, like log n and n, if we're multiplying with n and n, it will be n square. And only single n is here. So n log n is in between n and n square, right? That means we can write here like n square, n log n, n, and log n. So for the equation, so for the other type of sorting, like team sort or other sort, their complexity is like n log n. But I'm not going to discuss those things in detail. I'm just giving you their complexity. But in our case, it took n square. But it is easy to understand, though it is taking longer time, but it is easy to understand. To understand the sorting algorithm, this is the very first thing. Now the question is, what are the operations we have done here? Iteration and swapping. How can we swap? Did we use any swapping thing in this course? We haven't, right? Then how you can swap? Here is our list. How can we swap it? Just make it smaller. I have two numbers, or not two, five numbers, four numbers. 5, 4, 3, 2. 3, 2, 3. Okay. I would like to swap, for example, these two numbers. How can I access 4? If it is like L1 list, so it is L1 1 and this is L1 2, right? How can I swap it?
You could set aside a dummy variable to store the number you want to swap in.
Yeah. That's the trivial case. So whenever we are using any temporary variable or dummy variable, that's like a trivial case. That means I have two things. I need to swap. So what I can do, I can put it this like temporary holder and then put it here, then swap it, move it here, move it there. So what I can do for those two variables, I can create a temporary variable like a t. So what I can do, I can assign the t to the L11, right? Right now, t has what value? 4, right? Now, my goal is to swap it. So what I can do in this, maybe I can do these things in a reverse way. T is L1, then L1 1 is L1 2, right? So what is the L1 2? L1 2 is 2. Now the L1 1 is 2, but L1 2 is also 2, right? So right now, so where is my temporary variable? Like initially temporary variable was nothing. In the first statement, I just assigned the L1 value to t. Now the t value is 4. Still L1 value was 4 and L2 value is 2 in this operation, right? On the next run, I put the L2 value to L1. So now in the L1, I put the L2 value to L1 like 2, but I haven't changed anything to L2 value. So L2 value is also 2, right? But where is my 4? I put it in the temporary variable. So now in the L2 2, I put the t. This is how we can swap a number using a temporary variable. If we have two values, to swap it, we need to use a temporary variable to swap it. This is the trivial case. But the good thing in Python, you don't need to use a temporary variable. It is very easier. So here is my L1 1 and L1 2 is going to assign L1 1 and L1 2. That's it. So here's my tuple. Here's another tuple. This is just swapping. So for L1, oh, sorry, it should be 2 and 1. The 2 value will assign to 1 and 1 value is assigned to 2. We are not using a temporary variable. but you need to know the basic of swapping technique. Okay. Any question? So there's some advanced method, like how can you swap two numbers without using a temporary variable, without using these swapping things? Do you think of it? How can you do that? Can you swap two number without using any temporary variable, without using the Python swapping? It's a mathematical thing, actually.
I was thinking about that. I was trying to think of the formula that would like swap them.
Yeah. So you need to do some addition, subtraction, and all of those things.
Would it work if you did subtract the second number from the first number and then add that number to that number?
Something like that. I don't remember the exact
Maybe.
thing right now, but yeah, if you just
That works
search,
for this example, but I don't think it's
Yeah.
gonna work.
yeah, for this particular case, it is like easier. So swap two numbers without using temp variable. So here's the case. I have two numbers, 2 and 3. A is A plus B, like 5 right now. B is 5 minus 2, 3. Now B value is 2. I mean the A value is A minus B.
See, that's probably more correct than my my answer. It's okay though.
Yeah, at least you need to know those things. Okay.
Does it, I mean, considering it converts it to int, it only works on ints and floats, right?
Yeah, it can work yeah, definitely integer and float, definitely. But if they are like string or other things, you cannot. String or boolean, you cannot do that.
I want to figure out how you swap booleans.
It's easy. You don't need anything. If it is a true,
You just
swapping is
invert-
like false,
yeah.
right?
If the second
negative.
is false, set the first to false.
Yeah. It's easy to
Nothing
swap
much.
in.
If they match, just don't do anything, but if they're different. you just-
Exactly.
Oh, yeah.
First, you'll check if they're matched, don't do anything. They're the same.
And
If they're not matched,
just set them each to their inverse.
just reverse it.
Inverse, yeah, inverse. both.
Reverse it. Boolean is easy. Okay, so if I'm going to show you the bubble sort animation, so let me run this one again. So here's my value 65318724, excuse me, or it will check first two number 5 and 6. They are not matched. 6 and 3 swapped. Then 6 and 1. So you see it's a sliding window. Window is sliding throughout the end. 1 and 6 swap. And 6 and 8, you don't need to do anything. 8 and 7 swap. Then 8 and 2, yes, swap. Finally, 8 and 4, yeah, you need to swap it. And this is the only first run. At the first run, you're fixed. You're bubbling the 8 at the very end, so 8 is fixed. Then do the same thing again. 5 and 3, swap. 5 and 1, swap. 5 and 6, you don't need to. 6 and 7, yeah, you don't need to. 7 and 2, swap. 7 and 4, yeah, swap it. At the second run, you're fixing the 7 at the very end. Then do the same operation until 4. 3 and 1, swap it. 2 and 5, you don't need 2. 5 and 6, yeah, you don't need 2. 6 and 2, yeah, you swap it. And 6 and 4, yeah, you need to swap it. So at this run, third run, you're fixing 6. The next run, you will do the same thing until 4. Okay. 1 and 3, no, you don't need to do anything. 3 and 2, yeah, you need to swap it. You can see here at this point, everything is swapped, but still you need to check it. It's because you haven't gone through all the way, you haven't fixed that particular one. Okay, so this is how the bubble sort works. Now, if I need to write a code, how can I write a code? So here's the details of what the animation did. So here's the code. I need to know the length of the number, and I need to iterate through the 0 index to the length -1 for the first run. This is the first part, like iterating that many times. And for each run, what I need to do, swap it. Then I'm writing another loop, inner loop. In that particular loop, I will swap how many times? For the first time, it will swap until n. For the next time, n minus I. I means like we already have done the first one. Now we'll go the second one, third one. So on the first run, we already have fixed the 8. That's why we just remove the 1. So I is like first time 0. It is not subtracting anything from here. On the second run, it is like I is 1. That means n minus I is n minus I, that position. N minus I, second run, n minus I on the third run, n minus I in the fourth run, so on and so forth, for the inner swapping. So this is the swapping things. Now, when I'll swap, as long as the current value is greater than the next value. So J is the current value, J is the current value, J plus 1 is the next value. If the first value is higher, only we'll swap. Otherwise, we don't need to do anything. That's why I have an if condition. If the current value is greater than the next value, only we swap it. So J is J plus 1 and J plus 1 is J. If you would like to use the temporary variable, that could be different code. If you would like to use plus minus operation things that I have shown you, you can also do that. But that's the trickiest one. So that's why it's taking n squared time. This is like n time, and though it is like n minus 1, but we can remove the I. That's why it's taking n multiply n squared time. Any question about this code? Do you understand this code? For the I, it just how many times we need to iterate. That many items, we need to run that many times. And then for the J, what do you need to do? For each run, we need to check adjacent. And how long? As long as it ends. So since we have fixed to the previous one, so we can remove that part. We don't need to check it like, so we can write this way, n minus 1. That means it checks those things unnecessarily. It saves the time a little bit, not too much, but a little bit. So this will also work, but unnecessarily it will check 7 and 8, 5 and 6, 6 and 7, 7 and 8 all the time. We already have fixed it in the previous run. We don't need to check it again. So that's why to save some time, you can write like n minus I minus 1. Does that make sense? Okay, so this is the bubble sort. The advantage is that it is easy to understand, simple to implement, and I told you about these things. It is very slow for the larger data set. If it is like an 1 million data, it will take 1 million multiply 1 million time to sort, like n square, which is like slower than our traditional team sort or some other sorting algorithm. But it is easy to understand. I haven't added anything here, but I would like to discuss a little bit about the merge sort, as because we already have covered the binary searching last class. Merge sort is somehow related to binary searching. In the merge sort, it uses a different technique. What it does, it uses a divide and conquer technique. First it divide and then conquer. So for example, here's my list: 2, 5, 1, 3, 8, 6, 7. How many items? 3, 4, 5, 6, 7, and 4. Right? So this is the list. I would like to sort it. How merge sort does, it uses divide and conquer. The same way we divided in our binary search. How do you divide? Left and right and middle, right? So left and right and middle. Split it. Half and half. But we're not discarding anything. It's because in the binary search we have discarded based on some checking, but here we're not discarding, we're dividing one at a time. How long? Until we have a single element. This is the first divide. On the second divide, we can divide here, right? 2, 5. So let me write it. On the first divide, we have 2, 5, 1, and 3. And here 8, 6, 7, and 4. This is our first divide. On the second divide, again we divide here. So now we have 2, 5, and 1, 3. Here 8, 6, and 7, 4. Still, we don't have one single element. We need to divide it again. So 2, 5, 1, 3, 8, 6. You can see here like one single element in the list. 7 and 4. We cannot divide. So we can divide up to this position. We cannot divide beyond this one, right? It's because we have one single element. Now it's time to conquer or merge. That's why it's called like a merge sort. So now we'll check. Well, I have two things. I'm start merging with those two lists at a time. 2 and 5. Which one is smaller? 2, then 5. Again, we can merge it. 1 and 3. 6 and 8. So when we're merging, we can check those two items. Which one is smaller? Here again, we merge it. 4 and 7. So this is the first level merging. Then on the second level merging, what we'll check? This first item with the first item. Which one is smaller? 2 and 1. 1, right? So 1 is done. Then we have 3. 3 and 2. 2. Now we have 3 and 5. 3. Then only 5. Same thing here. 6 and 4. 4. Remove 4. Then 6 and 7. So when we're removing, that means 7 is the first point now. So we're checking one item at a time. 6 and 4, done 4. Then 6 and 7, 6. 6 done. Then 7 and 8, 7. Then 8. Now this is challenging. 1, 2, 3, 4, and 4, 6. So we have 1, 2, 3, 5. So 1, 2, 3, 5, and 4, 6, 7, 8. Right? This is the last merge. Now 1 with 4, 1, remove 1. Then 2 with 4, 2, remove 2. Then 3 with 4, 3, remove 3. Then 5 with 4, 4, remove 4. Then 5 with 6, 5. We don't have anything in the left one. So what I can do, I know these are sorted. We can put all of the rest item into here. Or we can check it here. There's nothing. So whenever you're checking, there is nothing actually. So this is basically a merge sort, divide and conquer. We're dividing one at a time until we have one single element. This until this position is the divide. Then from here, we need to merge or conquer. This is sort of a binary searching question.
So this is like one of those things that feels like a lot more work to human, but is actually a lot faster for computers.
Yes, compared to bubble sort.
I was gonna say, I guess the computer doesn't actually like start making comparisons until midway down, right?
It can compare. It is comparing two items, right? It is not comparing the whole thing. It is comparing one item at a time. If you just check here, the first item with the first item.
I meant like on the diagram being on the right half, it doesn't actually need to make a comparison to like make all those sortable sets, right?
Yeah.
I get it.
Does that make sense? Any more question, Lucas? Okay, and this particular technique takes, like, as I told you, n log n, but I'm not going to discuss about the whole details of how it takes n log n, but you'll learn those things later. Since you're saying it's like a half and half, that's why the log n comes, half things. Dividing takes log n time, conquering takes n time. In addition, it takes like n log n. But if I'm going to show you in a animation thing, the first divide, second divide. So we're done with the divide part. Now conquer. 5 and 6, sort it. 1 and 3, sort it. 8 and 7, sort it. 2 and 4 already sorted. Still not sorted. They're two different lists. So we need to create a new list with the sorted one. Now, one item at a time. It will check the first item with that first item. If there's nothing, just put all of those data to here. Okay. So this is basically the merge sort. As I told you, we're not going to cover details about the merge sort in this class, just to give you some hints that this is like a merge sort. You can sort it in this particular way. There are a lot of other type of sorting algorithm. I can show you another animation of insertion sort. Insertion sort is reverse of bubble sort. The bubble sort is like bubbling up to the end. The insertion sort is like looking for to insert in particular place. So let me show you the animation for insertion sort. You will check 6, go to the onward 5. Insert is like we need to put it here. Whenever we have a place, we'll swap it. We're not checking adjacent, we'll check all of those things. So you cannot put it in between 5 and 6. You need to put it to before 3. Same thing for 1. You cannot move it to 5 and 6 position, not 3 and 5 position. It should be before 3. 8, you don't need to do anything. 7, check with in between 6 and 8. Yes, it is the right place. You can put it here. 2 is the critical. You cannot put it in between 7 and 8. Neither 6 and 7, nor 5 and 6, nor 3 and 5, maybe in between 1 and 3. Same thing for 4. We'll check for the first 2. Not possible. In between 3 and 4, you can put it there. This is another type of sorting. So there are like a lot of sorting techniques. Insertion, bubble, merge are one of them. But there's some other like selection sort, maybe some compound one like team sort. They're using quick sort. Oh, there's another one like quick sort. So quick sort and merge sort, they're using those two type of things for team sort. Okay. Any question about the sorting basics? I don't ask you like you know everything in the sorting, because there are a lot of things in the sorting. Maybe you'll see 2 or 3 or multiple modules in 2420 or 1410 class. Okay. Any question? Yeah, if you don't have any question, then we are basically done.